So welcome, Amber, to this session. And thank you for taking out time. So for everyone, Amber did her PhD from University of Michigan in 2025 with Professor Musharraf Chaudhry. Her area of research during her PhD was efficiency in LLM serving systems, LLM inference systems. Most recently, she's been looking at agentic RL and how we can basically have agents doing research, scientific research. Currently, she is founder for Agent Native Research Lab. Before this, she has also been a research scientist at Meta, and where she has worked on LLM pre-training and post-training systems. So in today's talk, she's going to discuss various aspects of agents and how the emergence of these agents uh, are going to change the world of research. They're already changing, and how it's going to further impact how we write papers, how we do research, and so on. So welcome, Amber. Again, welcome to this session, and over to you, Amber, for taking this forward.
Thank you so much for the intro. Let me share my screen. Okay. Yeah. Thank you so much for inviting me to talk about my visions on agent-native research infrastructure. And let me start with a little bit introduction about myself. So Professor Drew already covered a lot, but I still want to go over it. I graduated last year from University of Michigan, and then I joined Meta for like less than a year, and then right now I founded my company like 2 months ago. My journey is like I start with like building machine learning systems, like how to train and serve large language model more efficiently. But by the end of 2024, I realized that that's just the beginning of coding agent. I realized that coding agents has the potentials of doing research for me, or even at some point were replacing me as a researcher. So by the end of 2024, I start realizing that I should do like AI scientist or AI for science instead of like doing research by myself. So I pivoted at that time and working on several research projects around like AI for science and trying to automate the scientific discovery for myself at first. And then like in the middle, I joined Meta and also doing the post-training, pre-training systems. But meanwhile, I do a lot of side project and build a cursor for science, actually helping any science or any researchers to do science more easier. And the mission is trying to democratize research. I saw a lot of users on my platforms. They're from different backgrounds, not just computer science. They're able to like use our tools to do like training or to run small experiment on GPUs more easier. And within just a few months, we reached like over 5,000 users, and at peak times, I have like over 50 paying users. And then after about this year, early this year, like OPAS is super great, but the cost is also super high. So I paused this line of side projects a bit. I realized I should working on more important things, and this is like the research infrastructure for AI scientists. And the motivation for this is also coming from like my experience of building the cursor for science, where I got a lot of user feedbacks from the platforms that they want me to have some kind of reproductions features that given the paper, you can just directly reproduce the results so that they can build on top of. So and then I think about this problem, I realized it is not my problem that it's not intelligence problem that we cannot reproduce a paper. It is mainly the ecosystem, the infrastructure is broken, that all the papers does not have all the details to reproduce the results. So that comes to my next page, that I think for building better AI scientists, it is not just the problem of intelligence, where I believe OpenAI and Anthropic will handle it very well. It is the problem of the underlying infrastructure becomes the bottleneck of the AI scientist. And I will spend most of the time talking about the paper agent-native research artifact. And at the end, I will cover some of more works, more thoughts that I've been thinking a lot along the way. So the new opportunities comes from like the AI scientists and human scientists are completely two different species. So basically, AI scientists can understand doing experiment and proposing hypotheses at infinite speed, but the underlying infrastructure are still built for human researchers for the past 100 years. And the infrastructure I meant can be like on the academic side can be the paper PDF, the peer review system, conferences, and on the enterprise R&D side, it can be all the software that we are using, even like Slack, GitHub, Weight and Bias. So because of all the software or the systems are built for human reviewers or human researchers, there's a gap that we are actually kind of slowing down how AI scientists can do research. So I start from paper PDF is because paper PDF as the protocol of documenting research knowledge is because I think if we look at the history, human wisdom start accumulating because we invent language, not because we become smarter. So similarly, I think to having this research language primitive for AI scientists is super important because as the media of documenting research knowledge, if we could have a more AI native way for like compounding research knowledge, then it's kind of kicking out the flying wheel for AI scientists. So I start with innovating research artifact. And everyone whoever doing research will know the process of producing paper PDF, where we have to hide all the very tedious intermediate process, like how we debug a program, how we fine-tune a systems day and night to optimize the performance. We have to hide all those process behind the paper and then generate a very polished story to convince human reviewers with like 8 pages and with only successful stories. And also on the other hand, human has this limited bandwidth of understanding everything that you did. So that is why in the paper PDF, we have to drop all those important details like the hyperparameters, like the exact descriptions, a lot of things that are super important for AI scientists to understand, reproduce, and extend the research. So in conclusion, like paper PDF is a compression of research, but it's not ideal for AI scientists who has unlimited bandwidth. So in the paper, I plan to propose a new format of research artifact called ARA. You can think it as a new unit of research package for agents, and it's basically covered these 4 layers. It's from like conceptual level claims to the implementation details, like all the code and configs, and the whole exploration trajectories, including the intermediate thinking process, the decision-making points, the dead ends, and the pivot. And also, it has the evidence layer, which contains all the ground truth results, all the raw numbers generated by the experiment, so that every claims is linked to the corresponding implementation, and all the it's actually in the next page, I think. Oh, no, really. Every implementation is linked to the raw numbers, and then every claims is actually auditable, and we can know what has been tried with, what has been not tried in the research. And with this structure, we are able to make a research artifact actually machine understandable, executable, and verifiable. I'll talk about more in the future slides and how we can leverage this protocol to do more things. So once we have finalized this ARA protocol, how can we actually generate this ARA protocols while we are doing research, or how can we convert this legacy research artifact like paper PDF and GitHub repo to an ARA protocol? And with ARA protocol, how can we do the review on top of that? That's also being discussed in the paper. So we basically trying to just start with some very easy agent skills so that everyone could use it. So before I talking about this agent skills that trying to produce ARA or review ARA, want to talk about new concept, which is not covered in this slides, which is agent AI native research. So I believe everyone today are using AI to do research as an interface to do research, either brainstorming. We're no longer like brainstorming linearly. We should actually using AI to brainstorm like more scalably, generating 10 ideas at a time, and trying to decide which one to do based on your research taste. And experimenting as well. We never write, or we no longer write a line of code, but delegate the experiment implementation and monitoring to the coding agent. And then also we don't really write the paper ourselves. We don't analyze the results too much, but more like we ask the right questions and let the coding agent to hand over the tedious work. So overall, this AI native research paradigm give us this opportunity to document agent native research artifact more easier, because previously it's just very hard for human researchers to document all the tedious process of research manually. It takes like us even longer time than writing the paper. But now with AI native research, we are able to just let the AI to be the observer of our research process and documenting everything that we did. And AI doesn't have this I don't know, they don't fear of sharing their way of failures. So it's kind of a better incentive among AI scientists to share their failed attempts. So with that, that's why we start with just releasing those agent skills, so that everyone who are using coding agent is able to integrate this within their workflow. So the first skill is called research manager. Basically, it's kind of a faithful observer while you're collaborating with your coding agents, and you can directly integrate it into your Claude.md, so that every sessions it will trigger the skills, and the skills will look at like what is your feedbacks to the agent, what is produced by the agent, and then it will try to document all the 4 layers protocols based on the research progress. And the second skill is called compiler, where if you input the legacy paper PDF and the GitHub repo, it will try its best to generate this ARA protocol or ARA format of research, but it will just do the best work of reverse engineering. But if there are any important decision-making or details is not covered in the legacy research artifact, it cannot do it well. So I'm mainly focusing on like the ongoing research. Whenever like AI is doing autonomous research, or we are using coding agent to do research, then research manager is able to document research in this format. And then we are able to share this ARA, the research in the ARA protocol with the community, and the community will understand like whole trajectory and the whole details of your research. And then on top of that, we also build a research visualizer, because the generated research artifact is entirely built for AI to comprehend. What if we want to comprehend the research process and the research claims? Then we basically build a research visualizer. Basically, you can see like what is the agent progress. It's essentially especially very useful if you are doing like auto research. Basically, you design a goal and let the agent to do like overnight or a few days of work. Then it can help you visualize like what are the dead ends, what are the thinking process of the agent. And the last skill is the rigor reviewer, which basically it helps you to gut real AI scientist behaviors, whether it's doing reward hacking, whether it's hallucinating, whether it's following the rules of scientific rigor, like doing controlled experiment and faithfully document the results. But this is still an agent skill that is trying, like kind of using a large language model as a judge, try best to follow those rules. But I have a lot of future work trying to use like formal system and the neurosymbolic ways to make sure that it's actually got real large language model behavior instead of using another large language model. So we have proposed ARA, but how does it work? How can it benefit our research? So there's some 3 levels of experiment that I'm trying to showcase. With ARA, we are able to outperform paper PDF plus ARA in terms of letting agent better understand the research, letting agent better reproduce the research and extend the research. And the 2 data set that we are using is the paper bench, which contains over 20 overall paper from ICML, and they have invited their authors to manually label like over 8,000 rubrics inside the papers. So with like those extra information from the authors, we are able to design the questions that asking for like more details about the paper. So to test whether with ARA, basically we use this extra details to construct the ARA, and then when we ask questions, we are basically asking for this extra details. So where paper PDF does not contains. And also we use these rubrics to ask AI to reproduce the result of the paper with ARA and compare to paper PDF. And we are able to show that with ARA we have better reproduction rate. And RE bench, on the other hand, contains 7 close-ended AI R&D hill climbing tasks with well-defined objectives. And also in the next slides, we will show that we are able to outperform the baseline in 5 tasks because we have recorded all the failure attempts inside ARA compared to the legacy research artifact only has the successful solutions. And it basically saves the AI scientists a lot of time on trying all the dead ends. Yeah, so overall, we are able to outperform like the legacy research artifact in terms of understanding, reproduction, and extensions on the paper bench and the RE bench. And this is my recent paper, Agent Native Research Artifact. With this protocol, we are actually able to do more things on top of it. And these 3 layers are, I believe, is a very important layers. Well, if you are working on AI scientists, the first layer is verifications. I'll talk about more, but AI can generate research at infinite speed. If you cannot verify a result, it's basically a waste of efforts. And second is the research taste. You have to decide, or you or AI have to decide what is the next decisions, what is the next hypothesis to try out, what is the important problems. Without that, if you can do everything very rigorous, and it's basically maybe you're falling to some local optimum, and doing research is explore a unknown world. So how can you let your AI scientist or yourself explore the unknown world more efficient? And the last one is evaluations. I believe there are a lot of evaluations out there trying to benchmark whether AI can do science well. But AI, or at least there are enough benchmarks on coding agent, but I believe there are still empty space that people are not aware of the complexity of AI research tasks, which is quite long horizon and quite open-ended. How can we evaluate this kind of task for AI scientists? And having the evaluation set up is quite important because it will guide your systems or frontier model labs to know how to improve their models. So I will cover each of layers briefly, and each of layers is based on my previous work. So first of all, this is a side project. I'm trying to motivate how AI is easy to hallucinate or reward hacking. And then I'm trying to motivate, it is super important to actually have this verification layer to guard real AI behaviors. So here I use a post-train bench data and agent trajectory over 1,000 1,000 agent trajectories that I'm trying to analyze their behaviors on reward hackings. And this bar plot shows like the hack rate, and the colors represent how it's easy to evade the judge. So you can see like Fable 5 is super smart. It almost evade the judge every time, but and its hack rate is around like 10%. And want to like some fun facts that we've discovered while we trying to analyze the agent behavior is that we have this question of while an agent is doing reward hacking, is it because the problem is too hard or it's too easy to hack? Or is it because of the integrity of the large language model that they just want to hack the system even before trying anything? Or how good they are on just hide the fact that they're reward hacking? How good they are like at rationalize the behavior that they did. So we did a lot of analyze on these 5 dimensions, and we find that it's really interesting that better model are just better at reward hacking the systems, and we find that chain of thought are just making model better at justifying their cheatings, and a lot of others. And I want to talk about this is like GPT and Claude actually display different behaviors of behavior patterns in terms of reward hacking. And GPT is really good at just hack the scoreboard. So they usually will, for example, just change a tokenizer, and so that the model will output a certain token in order to cheat the judge, or they can like just zero out a certain model layer in order to force a single target token to be outputted. And on the other hand, Claude is another kind of hacker that usually when they train the models like over 90% or 80% of the accuracy, and then they start reading the test set or the judge, the evaluation set, and then they trying to make up some like synthetic data, trying to put it into the training set and then fine tuning on top of it. And then they probably will get like 100% scores after they do this kind of reward hacking. So it's just quite interesting to understand their behaviors. And then this is the like reward hacking behavior of Claude and GPT. And then we realized that no matter how smart your model is, and even worse, like the smarter you are, you're just better at reward hacking and evade the judge. So having this rigor guarantee is very important. And in the paper, we argue that, or actually we cited someone else, like science without rigor is reckless. So in this paper, which is I did at the end of 2024 and released like last year, is that we were trying to propose AI scientists that with rigor enhanced. So what we propose is two loop, one inner loop rigor guarantee and an outer loop rigor guarantee that trying to cover like more generic rigor checking AI research. So at a high level, we still have this loop that AI can decide when to propose a hypothesis, design experiment, run experiment, and analyze results. And within every step, we have this inner check. I will give you some examples later on, but basically try to prevent some regular reward hacking or hallucination patterns. And then for the outer loop, when trying to learn from those scientific rigor which has been proposed like 100 years. For example, how to do research, we have to do controlled experiment. Another paradigm is like we have to propose hypothesis first and then do the experiment. And then when we analyze the result, we have to tie back to the original hypothesis instead of just interpret the results without looking at the hypothesis. And usually that will let the model just to deviate from the original intent. And also in the paper, which is like almost 2 years ago, 1.5 years ago, we also proposed this experiment knowledge module, which is kind of the ARA, early version of ARA, then trying to document all the experiment results and trying to crystallize experiment results into insights. So this is just examples on the inner loop that we have laid out some common patterns when AI will hallucinate or do reward hackings and trying to prevent it. For example, even today, AI is really good at like just generating some mock data that instead of using the real data, it generates some synthetic data and say, trying to prove that your hypothesis is correct. It's also another problem of large language model that it's trained on those successful paths a lot because all the papers only have the successful paths to reach a conclusion. So large language model is really good at like prove your hypothesis is correct. Anyway, so we have identified a lot of reward hacking pattern trying to avoid it. So that is it. The second work is about the research taste. So as I said, you can make sure every step you did is correct, but if you cannot decide the good directions, your efforts is also wasted. Like directions is very important today that agent can hand over all the execution very well. And now it's very important to either identify the important problems or choose the hypothesis worth testing, or even on the lower level, we call it research intuition. Among all the say hyperparameters or among all the techniques, which is the most promising directions. So this paper, I focus on the most higher level, which is the research higher two level, research taste and research judgment, where I wonder how does all those research innovation comes for those top tier machine learning conferences. So I am trying to extract the thinking behavior, thinking patterns behind all those top AI research papers. What I did is we extract those high quality papers from ICML Europe's iClear for the past 3 years and only select those oral and spotlight papers. And for each of the paper, extract the top 10 citations or top 10 important related works from each papers. And then we try to construct this chain of thought behind the papers, like from paper ABC, and how does the innovation happens that motivate us to produce the current oral papers. And then I'm trying to extract those connections. And I also did analysis on this innovation patterns, and I summarize this top 3 in the paper. There are like more analysis, but here I just show you like top 3 kind of thinking patterns behind the oral paper and spotlight paper. First is the gap-driven reframing. So you realize that a certain related work cannot do something well, so you're trying to patch this paper with a more stronger solutions and consider more scenario, more preconditions. And the second is the cross-domain synthesis. Basically, it trying to get papers from domain A and another paper from domain B and trying to do some cross-disciplinary innovations. It's also very common that we're trying to borrow a lot of insights from like neuroscience to when we do AI research. And the representation shift means you're trying to just use another definition from another domain and trying to apply the similar definition or concept in the current systems, and then reframe the problems. Yeah. So anyway, a lot of research tastes or the thinking patterns actually can be reused, and we can use this thinking patterns or chain of thought to train another language model so that it can learn from how humans think about the research problem. When we read a paper, how should we decide what is the next step to do? However, as I said, papers hide the majority of the thinking process. We only know like how the successful story looks like. We don't know like the actual narratives in the middle, the pivoting point, or the actual very nuanced sparking times. So it would be better if we can just sit behind or beside Einstein to understand how they think about the problems. It definitely is not just an apple falling from the tree, that simple, but like research intuition or research taste is actually more complicated than that. Okay, so after the rigor and research taste come to the evaluation, as I said, I don't know if you have read an article called the second half of AI, which is evaluation. Evaluation is very important because it basically is the driven your internal model development of frontier lab. So if we could do the evaluation more comprehensively, then we are able to build better model, can do science. And the problem of existing evaluation is that they're mostly heavily focused on the coding agent or like some daily task like white collar tasks. But for research tasks, it's very different. It's very long, it's very hard, and it's very open-ended. And that means, for example, coding agent almost only check the final outcome and try to test on several test cases. And this is no longer viable because research is not just about whether you get the final answer correct. It is also about the process, that every step you did is valuable, even though you reach some wrong answers. And also open-ended, this is also open-ended, so there's almost no ground truth for you to judge whether AI agent is doing the correct things or not. So we have to reimagine the whole evaluation pipelines, starting from like proposing hypothesis. Even just proposing hypothesis, we can have a line of benchmark methodologies because you can benchmark how diversity the hypothesis that you propose and how likely or feasibly your hypothesis is. And then we also apply similar things to design experiment, implement experiment, and even executing experiment, to all the way to the analyzing the results. So in this work, which I did also last year, I'm trying to curate over 400 research tasks from top tier papers, and we have over like 12K fine-grained checks, all grounded in the published experiment, trying to understand how AI can do end-to-end AI research tasks. Because it's almost published a year ago, so a lot of the numbers doesn't make sense, so I didn't put the numbers here. So at that time, we find that only 0.5 of the agents can do end-to-end research and almost hit all the criteria that we established. But now I believe this number could be very high. So also basically we have several setups that the agent input is the research question and the high level method, and we trying to see if it can reach the same conclusion of the original papers. And we have this integrity gate and trying to, as I said, to see whether the agent can do genuine experiment and not do reward hacking and trying to get online and see the original GitHub repo, and don't hard code the data or do any fake data. So we also in this paper we focus a lot on the rigor instead of on the like curiosity on the diversity side. But I believe it will be a very important future work if we can focus on the research taste side. Yeah, and I'm not showing the result because it's quite outdated, and this paper is also accepted by iClear this year. Yeah, with that, all those different layers in the research ecosystem, I want to conclude my talk that I think intelligence is super important, but the bottleneck now is the research ecosystem that we are basically running this brilliant AI scientists on a very outdated infrastructure. And if we could have this infrastructure built right, AI scientists can basically work on himself and forever. And also we want to build this ecosystem that multiple AI scientists can collaborate together and to make scientific breakthrough happens. Because I believe like scientific breakthrough, if we look at the history, is never coming from a single or individual brilliant scientist. It's always coming from a group of people that pushing toward different directions, or even over generation, they are overturning the research from previous generations. So having this ecosystem that allow AI scientists to collaborate easy is our missions. Yeah, thank you everyone. I'm happy to take more questions.
Great. Thanks, Amber. This was lovely, and as you can see, the emoji reactions, the chat was also incredibly active throughout the discussion. So thank you.
So thanks, Amber. So I'll start with some of the questions which the audience is asking. So maybe first I'll ask my own question. So where do you see this? I mean, let's say, how do we basically make sure that we are moving in the direction we are proposing as a research community? I mean, ARA is very good, nice to see and discuss, but like in terms of adaptability and making it acceptable in the broader research community, how do we move forward?
Yeah, that's a good question, and that's a very related to the incentive mechanisms inside the community. I think it will take like more than 5 years at least to actually adopt something like ARA in a human community. But I'm very optimistic on AI scientist community that AI does not have this shame of fearing publishing their failure results or failure attempts intermediate thinking process. And I also am a firm believer of like fully autonomous AI scientists, because I more and more realize that AI now human becomes the bottleneck of the AI loop, even though I know AI hallucinates a lot. But I really believe that AI will self-evolving over the time when the time comes, when the singularity point comes. So at that point, it's just much easier for them to release some research artifact in the format of ARA.
So yeah, sounds good. There's a question from Nagaraju, and he's asking like, how can we better adapt? How can agentic research better include negative results as part of research artifacts? I think it's partly covered maybe, but you can elaborate on it. Like generally, the academic research is optimized for positive results. We don't add the negative results, but how can agentic research better adapt to or include negative results?
And
Yeah.
I mean, sorry, Amber, but just to extend to that, right? Like, this is also like a commonly known failure mode in LLMs right now, that they seem to be over optimistic and they seem to proclaim Eureka, which can all be tied back to, let's say, the absence of these negative results in like the training data or multiple things. So it'd be good to like sort of, if you could also address not only how do we publish more negative results and use ARA, but also how do you see that tendency just going away in these models without us having to put these results out?
Yeah, as you said, it's also a problem of large language model. It only see the successful results. So maybe it will be fun that those frontier labs are actually crowdsourcing those failure results or reward those failure results to train their model. But on the other hand, I do see a lot of workshop that are trying to only accept the papers that were talking about failure results. And I do see this incentive from the community, but not necessarily from the conference side, that if people are releasing this blog post that talking about how they fail so many times for important questions, and those kind of blogs usually got a lot of attentions on Twitter. So I think, yeah, as I said, also AI scientist does not have this problem of sharing their failures. So yeah.
Sounds good.
Do you not foresee that the traces in ARA, for instance, them sort of exploding, especially in certain kind of research problems, such as, let's say, architecture explosion, right? Don't you see So how do you imagine agents as well as, let's say, human readers to surpassing that issue?
You mean architecture exploration? Is like too many model architecture?
Yeah, I gather. Yeah, like as you're exploring different architectures, you'd have insane number of traces because you'd explore a far wider search area. So how do you sort of make sure that is that not too much information for another agent when they're parsing through the ARA artifact from a
Oh,
particular? Yeah.
I see. Yeah, yeah. There's a trade-off. If you faithfully record everything, it's probably too much noise. I also have a lot of discussion on this. How can we make sure there's this very high signal ARA that doesn't contain like unuseful information? But I think it's quite important to actually sit down and understand what is the valuable information to maintain.
So first question is reward hacking and ethical guidelines or integrity. Is ethics and integrity, are these two the same thing or different? And how can we avoid these failure modes in these AI agents?
Yeah, good questions. I think these are different dimensions of the agent or AI abilities, because our analysis that some agents just decide to do reward hacking from the very beginning, and that basically means they're not integrate. Some agents just decide to do reward hacking after they fail many times. I think this is some different behaviors, but if you look at their capabilities, they can be both great. So I think it's also kind of a safety problem. You can be very smart, but you can just be nice, not cheating people. Yeah, they are separate.
Okay. Yeah, I mean, so the follow-up question is like, how do we basically move towards a world where they are not doing this reward hacking, or
Yeah.
where they have this ethics and integrity?
Yeah, so two sides. One is the training time. Well, we can build more robust RL environment so that even the agent want to cheat, but they cannot. They're penalized by cheating the systems. And another side is the testing time, where we can, as I said, we can do a lot of guardrail, either using large language model or using even formal system trying to penalize AI's behavior. But I believe it's just very hard because when AI getting smarter, it just inventing more creative way of reward hacking. So it might be just a continuous problems while we developing better AI.
Sure. So one more question around trace explosion, or the amount of information we are storing in this ARA. So how do we basically compress these traces based on like what is important, what is not important? Is there a way to figure that out?
Yes, right now we don't do compression, like the trajectory will faithfully record everything, but we do have this crystallizing step that after a long step or a lot of trails, we are trying to crystallizing the insights out of like, for say, 10 experiment. And for that, there are different layers that maybe it's just enough for you to just look at the claim layer, which is very high signal. If you look at the trace layer, it's probably low signal. But I think it's open problem. We build the infrastructure, and follow-on researchers can working on building more efficient and high signal ARA. Yeah.
Sounds good. One more question from Rishabh, who's asking like, how do you keep yourselves updated with the such fast-moving research, especially in this field of AI agents and LLMs?
And if I must extend that question a bit, Amber, like, do you find yourself sort of, going to, let's say, ARA kind of representations of papers now more as opposed to reading actual paper PDFs?
I think people are still like releasing paper PDF as the right way among human research community. But I also release a lot of post recently that I believe this is the right format for AI scientists to compound their knowledge. Recently, I have this blog post. I call it AI should build its own research world model. And this research world model essentially is a external memory, or say research intuition, that because when human doing research, we grow this intuition in our brain, but AI scientists not have this external brain if we're just doing test time compute. So having this ARA as a intuition or external brain will be very useful for AI scientists to compound the knowledge. So from first principles, it's actually very useful for AI scientists to do research. But for human scientists, we still care about whether people can see my paper on arXiv or not. Sorry, another question is, how can I keep up with today's research? I think, but I already graduated, so I can say that I don't care about the amount of the paper. But if you can produce 10 papers, it doesn't make no difference like you produce 100 papers. So I think today, like the paper quality matters more than ever because generating paper is so easy. And doing some research that actually is impactful is more important than generating another paper. Yeah, I see also people are like raising their hands, maybe.
Yeah, Anish, please go ahead.
Sancham.
Hello, Amber. Thanks for this really nice talk. I have a lot of reading to do now. Thanks for because of all the links that Drew shared. My question was that in this ARA system, the scientific discovery trajectory is very well defined in the sense that you have a hypothesis, you do experiments, you do proper controls, and then your experiments either make you change your hypothesis or they reinforce it. That is fine. But I think in the history of science, there are also many experiments which do not follow this structure, no? Where like it was just pure serendipity, or you were doing experiment, like basically data came first and the understanding or hypothesis came later. Like some experiment hinted that something else might be happening, right? So hypothesis might come a bit later than your analysis of data. Will this structure or this AI scientist built on this structure will it be able to capture such kind of non it's not that straightforward loops?
Yeah. I think it's very valuable as long as it's lead you to correct the results or say the reward. So during the training time, I think no one is actually forcing AI to form a structure of doing research, but more like maybe during SFT, we know this is the best structure. But during RL, AI have this freedom of choosing their path of doing research, either like having the data first or having the hypothesis first. Yeah, whichever makes more sense for them. Yeah.
Okay, perfect. Nice, thank you.
Or maybe Satish.
Yeah.
Hey Amber, thanks for the presentation. I mean, yeah, there's a lot of stuff to like read upon. But I was wondering, you were mentioning a slide in your deck, like saying about hypothesis, right? Let's say we are using this research scientist and we give it a problem statement and a relevant data for it to evaluate a hypothesis. But like as Anish was saying now, it is not that straightforward. Even for a well-defined problem, you often come up with like these intermediate hypotheses which change based on results, right? Based on your experience, because you had run this framework on multiple papers replicating, especially for these hypothesis testing, it's a chain of hypotheses, right? It starts somewhere and then it recursively. I don't know. I have a bias that it might diverge from what you wanted to do or humans wanted to do because of its hallucination. So does ARIA has anything, any component in the framework which controls or measures this, or is this part of your future work? I'm just curious.
Measure the deviation or
measure the deviation, thereby you can course correct, because or else only at the end of its trial, you will get to know, oh, all the way it had been hallucinating and there's a lot of aberration from what I wanted it to do.
Yeah, I think a lot of companies are working it, but not like as the main goal, but making sure AI does not hallucinate, as I said, reward hacking is very important, especially AI are doing more and more like longer time horizon task. Over days, if you hallucinate in the middle, that means like the rest of work are wasted. So I think a lot of company or university, they're treating it seriously now.
Cool. Thank you.
I think we have one great question in the chat, Amber, by Nanta, I think, which would be great to take. And then, of course, we have a final question that we're asking all the speakers at the conference as well. But before we get to that, just Nanta's question on, hey, if you think verification by humans is not relevant anymore in scientific research, how far will this go? And if human cannot keep up with the new discovery, what is the point of the new discovery? If I might just sort of extend this question a little bit, of course, ARA's one step forward in sort of verifying AI science, right? But if you had to sort of take this idea of humans not being relevant to scientific verification and just sort of really extend it into the future using infrastructure such as ARA, what is the kind of future that you see for verification in science?
Yeah, that's a great question. So I recently have wrote an article. It's called "The End of Human in the Loop." So I do believe at some point when AI cannot gain values from humans, so basically squeeze all the humans' data or expert data, then AI should just explore the world by himself, rather than giving feedbacks from human. But human may be still on the loop, maybe supervising the research. So I believe, well, that's just my judge, that there will be only 0.1% of the top researcher will be needed at that point to supervise AI's generated research. And there's definitely value of doing more research because there are so many unsolved problems in the world, like teleport, going to Mars, and longevity. So the science will continue, but just how human like position themselves in the loop will be different.
That's great. That's a great place to sort of, since we're almost on time, also wrap up the question with a final question. That if you do actually foresee this future where humans will find it incredibly hard to evaluate AI output and a lot of science will be done by AI, what do you think will remain the human edge? Let's say 10 years from now or by 2040, like, and as a young researcher, because a lot of the folks in the audience are young researchers, what do you think they should focus on? And also, do you think they should putting out their papers in the ARA format more often than, let's say, putting up a PDF? Any inputs would be great.
Yeah, for sure. Please write your paper, write your research in the format of ARA. And as a important skills is always be curious and keep learning and be good at learning new things. And in the recent few years, we can still say like research taste is a mode for human researchers. We even like spend a few years to build up the research taste. But I think from first principle, research taste is still learnable. So at some point, AI will know the research taste and know how to allocate the resources, because research taste is basically a resource allocation algorithm given 10 important questions, which one to pursue. And human will still guardrail the research heading to, like at least not hurting human, right? But if you ask me like 10 years, I cannot imagine, but more like I'm trying to be curious, having the ability to learn and always open to change. Yeah.